In this video, we're going to go over some application questions involving the use of integrals. In question 1, it says suppose that the temperature of a cup of tea, t minutes after it is poured, is given by the following equation, where k equals 1 over 53. And you're asked what's the average temperature of the tea during the first 40 minutes after it is poured. Right off the bat, we know that our interval is going to be from 0 to 40. Because the time has to start at 0 and end at 40 minutes. We also know that we're being asked about the average temperature, which we can denote by capital T with a little bar above it to indicate the average value. And we know that capital T of T is going to give us units of some temperature, which we can call degrees Celsius. If you wanted to do Fahrenheit or Kelvin, you could, but we'll just do degrees Celsius to keep it simple. And then for average value, we can actually use the following equation. We can say that the average value involving integrals is equal to 1 over b minus a multiplied by the definite integral from a to b of f of x dx, where b is our bigger number and a is our smaller number. So in our case, a is going to be 0 and b is going to be 40. So let's go ahead and try to solve this. So we can say that capital T of t is equal to 29 plus 75 e to the power of negative 1 over 53 t. And so we can call the average value capital T with the bar above it. And this will be equal to 1 over 40 minus 0 multiplied by the definite integral from 0 to 40 of T of t dt. And we know that this is in minutes. And we know that capital T of t is in degrees Celsius. And dt represents small changes in the time over the interval, which we can say is minutes. And so off to the side for a second, this is 1 over time, which is 1 over minutes. So we'll say 1 over minutes. And we're multiplying it by the integral, which involves degrees Celsius and minutes. And as we can see, the minutes are simply just going to cancel out, and we're going to be left with an answer in degrees Celsius, which is exactly what the question is asking for. So we already know this is going to work out perfectly. So try to understand why this equation works and how it works rather than just memorizing the steps. So now we can go ahead and evaluate this. I can go ahead and simplify this to 1 over 40 multiplied by the definite integral from 0 to 40 of 29 plus 75 e to the power of negative 1 over 53, and this is all multiplied by dt. And I noticed that inside of here we have addition, which is a sum, and so we can use the sum rule of integrals and break this into 2 chunks. So I can go ahead and say this is equal to 1 over 40 multiplied by the definite integral from 0 to 40 of 29 dt plus 1 over 40 multiplied by the 75, which I'm going to pull in front of the integral sign, multiplied by the definite integral from 0 to 40 of e to the negative 1 over 53t. And don't forget the dt at the end. And so now we can go ahead and evaluate this even more. And I see right here we have to take the antiderivative of e to the negative 1 over 53t. So just be careful here. We can recall that if you have, let's say, a derivative of e to the 2x, and I asked you for its antiderivative, the antiderivative would simply just be e to the 2x, and I'm going to divide by 2. And why would I divide by 2? It's because if you take the derivative of e to the 2x, you're going to get 2 multiplied by e to the 2x. But in this derivative here, in this equation, we don't have a 2 in front. So in order to get rid of that 2, we need to divide by 2 to get rid of that. So in here as well, we're going to apply the same logic. So we're going to evaluate the integrals now. So 1 over 40 multiplied by the integral of this, which will just be 29x, or 29t, because these are t values. And I'll just go ahead and move the 29t to the numerator. And this will be evaluated when t is equal to 40 and 0 minus the other integral, so 75 divided by 40 So I'll just have e to the negative 1 over 53t divided by the derivative of the inside, which would just be negative 1 over 53t. However, this is the same thing as saying multiplied by negative 53. So instead of this ugly looking division, we're just going to change it to multiplication. So I'm going to change this to multiplying by negative 53, and I'm also going to multiply it with the 75 over 40 we already have in front. And so by doing that, we're going to get 795 over 8 e to the negative 1 over 53t. And this will be evaluated at 40 and 0. So let's go ahead and do this now. So we have 29 multiplied by 40 divided by 40 minus 29 multiplied by 0 divided by 40. And then we have 795 divided by 8 multiplied by e to the negative 1 over 53 times 40. And then minus 795 divided by 8 e to the negative 1 over 53 multiplied by 0. And right off the bat, I know that this is going to equal to 0. And this is going to be e to the 0, which is just equal to 1. Likewise here, I'm going to have 29 times 0, which is a 0, so this entire thing will just go away. This 40 and 40 will cancel out, so that simplifies a lot for us. So now we have 29 minus 795 divided by 8 multiplied by e to the negative 40 over 53 plus 795 divided by 8. Should be minus actually. And then we can simplify this even more by distributing the negatives inside the brackets. So we can say 29 minus 795 divided by 8 multiplied by e to the negative 40 over 53 plus 795 divided by 8. And then adding this up together like terms, we're going to get 1,227 divided by 8 minus 795 over 8 multiplied by e to the negative 40 over 53. And so this would be your final answer. And let's say the question asked for you to round it to something like 2 decimal places. The answer would be approximately 81.65 degrees Celsius. In this next question, we're told that the serum concentration of a drug taken orally at time t equals 0 is modeled by the following differential equation, where the concentration CFT is measured in nanograms per milliliter and time t is measured in minutes. If we assume that the drug was only taken once, what would be the total change in concentration over the lifetime of the drug? To start, because we're asked about the lifetime of the drug, we would have to start when time is at 0, and we'd go until infinity. And then we know that the concentration is in nanograms per milliliter. And we can represent that as dC, which is going to be small changes in concentration, which is in nanograms per milliliter. And in this equation, we have concentration divided by time. So this is simply just nanograms per milliliter per minutes. I can now go ahead and set up a definite integral for this equation right here. We can say that this is the definite integral from 0 to infinity of dc over dt multiplied by dt. And so by doing this, we can get the dt's to cancel out, and we're going to get a final answer in just concentration, which is what the question is asking for. So try to understand why and how this equation works rather than just memorizing it. Now keep in mind that this is an improper integral because we're going from 0 to infinity, and you can't really plug in infinity, so we're going to have to change up the notation a little bit here. We're going to call infinity some other variable such as capital T, and we're going to take the limit and see what happens as t approaches infinity. So we can say that this is equal to the limit as t approaches infinity multiplied by the definite integral from 0 to t of 569 t e to the negative 8t squared. And don't forget your dt at the end. I now notice that there is a constant inside of my integral, and I can simply take this constant and I could pull it in front of the integral sign. This is equal to the limit as t approaches infinity multiplied by 569 multiplied by the definite integral from 0 to t of little t e to the negative 8t squared dt. And so now I want to evaluate this integral right here. However, right now I can't do that because this t is causing some issues. I want to get rid of it somehow, and to do that we could use u substitution. We could do that by setting u equal to the exponent. And why the exponent? That's because when we take its derivative, it's going to be negative 16t. And so by doing that, we can easily get rid of this t. So this will be du equals negative 16t dt. And solving for dt, we get du divided by negative 16t is equal to dt. So let's go ahead and sub that in right now. So we can say this is the limit as t approaches infinity, 569 multiplied by the definite integral from 0 to t of t multiplied by e to the u multiplied by du over negative 16. And t at the end as well. And then we see that the t's simply just cancel out, and then we're just left with e to the power of u multiplied by du, and we also have a constant of negative 1 over 16 inside the integral. So what I'm going to do is I'm going to take that negative 1 over 16, pull that out to the front as well, and multiply it with the 569 that we already have. So this will be the limit as capital T approaches infinity of negative 569 over 16 multiplied by the definite integral from 0 to capital T of e to the u du. And so we know how to take the integral of this pretty easily. It's just going to be the limit as t approaches infinity of negative 569 over 16 multiplied by e to the u. And recall that we said that u is equal to negative 8t squared. So I'm going to go ahead and replace that right now. And because we're going to plug in infinity eventually, I'm just going to use the fact that e to the negative power is the same thing as saying 1 over e to that power. So I'm going to move this into the denominator. And so we can say 569 divided by 16e to the 8t squared. And this will be all evaluated at capital T and 0. So let's go ahead and do that now. So we'll say negative 569 over 16e, 8 multiplied by capital T squared, minus 569 divided by 16e to the 8 0 squared. And right off the bat, I know that this is going to give me e to the 0, which is just 1. And this double negative should become a positive. So just watch out for that. And so now we're going to get the limit as big T approaches infinity of negative 569 over 16e to the power of 8 big T squared plus 569 divided by 16. And right off the bat, we know if you go ahead and plug in infinity into here, you're going to get 569 divided by a huge number. And so something divided by a huge number is going to make that thing approach 0. So this is essentially just going to go away and approach 0. And so your final answer is going to be 569 over 16 nanograms per milliliter. And if the question asks you for like decimal places, then this is approximately equal to 35.6 nanograms per milliliter.